In this lesson we will review exponentials and logarithms again, and this is just in preparation to use calculus with logs and exponentials. So no calculus today, just a quick review. So we can use a palette to graph this. We'd have the y-intercept, and the x-intercept, so the y-intercept is when the x equals 0, the x-intercept is when the y equals 0, and we will subtract 1 and use the natural log. And this is imaginary, so we won't have an x-intercept. We have 0, 1 is the y-intercept. There's no x-intercept. And let's choose some x values. On the calculator we can get that. 2.71 plus 1 is 3.71, and if we had a negative 3 we would be at 1.05. Negative 1 is let's go back here. This is e to the 0 is 1, 1 plus 1 is 2, so that's at 2, not at 1. We don't have that point. Negative 1, we go up 1.3, negative 1, 1.3, and 1, we go up 3.7. At negative 3, we go to 1. Negative 3, go to 1, 1.05. So if we don't know where the horizontal asymptote is, we can see that the y values are getting close to 1. We also see a vertical shift of 1. So the asymptote is at y equals 1. All right. Try that one. Pause the video. E to the negative 2 is about 0.135. So we have 0, 0.135. X-intercept when the y is 0. We can just do natural log since there's no addition over here. And this is undefined. So there's no x-intercept. We can choose some x values. E to the 2 minus 2 is e to the 0. That's easy to do without a calculator. Here we have e to the 1 minus 2. That's e to the negative 1. e to the negative 1 is 0.37 approximately. Here we have e to the 0 minus 2, e to the negative 2. We already have that as the y-intercept. E to the 4 minus 2 is about 7.39. So at 2 we go to 1. 0 is 0.1. 1 is 0.3. At 4 we'll be up at 7, and we can see the graph going like that. It looks like the asymptote is at y equals 0. And another way to see that the asymptote is going to stay at y equals 0 is because there's no vertical shift, there's a horizontal shift. So a horizontal shift won't change the horizontal asymptote. And the y-intercept is when x is 0, so that'll be natural log of 0 plus 1. And that says, find the exponent of e that gives you 1. The exponent of e is going to be 0. Remember that ln of x is log base e of x. Find the exponent of e to give you this number. Find the exponent of e that gives you this number. The exponent would be 0. So the y-intercept is 0. X-intercept is when the y equals 0. Natural log x plus 1. And to cancel the natural log, we do the inverse of natural log, which is exponentiating with the base e. E to the 0 is 1, and that's going to be x equals 0, so we get 0, 0 for the x-intercept. And let's see what happens at 1. At 1, we get 0.69. At 1/2 is 0.4. At negative 1/2, negative 0.69. And at 1, we're at 0.69. At 1/2, 0.4. And negative 1/2 is negative 0.69. So we can see it curving like that. The horizontal shift is 1 to the left. Another way to find the asymptote is what number makes this undefined. So a negative 1 makes it undefined, and that's where the asymptote is going to be at negative 1. X equals negative 1. And graph that. Pause the video. The y-intercept, we have log base 2 of 0 plus 1. Find the exponent of 2 that gives you 0. Well, there is no exponent of 2 that gives you 0. This is undefined. So there's no y-intercept. X-intercept. subtract 1, and exponentiate base 2. So we have an x-intercept of 1/2, 0. And let's see what's happening at 1. Log base 2 of 1 plus 1. To what power do you raise 2 to get 1? 0 plus 1 is 1. And then to what power, or find the exponent of 2 that gives you 2. What exponent of 2 gives you 2? That's 1 plus 1. So we have 1, 1, 2, 2, and the x value that makes this undefined is 0. So we know there's an asymptote at 0. And once you know the asymptote, you'll know that this is going to curve like that. The asymptote is x equals 0. All right. So more characteristics of logarithms, properties of logarithms. We can expand expressions. So whenever we see division, we can change that into subtraction. We can change the multiplication into addition. We can also move the powers out as coefficients. So let's start with the subtraction. Log of xy squared minus log z. It would be a mistake to put the 2 out right now because the 2 is only on the y. We don't have 2 on the whole argument, the exponent of 2. So now we're going to break that up as log x plus log y squared and now we can move the 2 out as a coefficient. Alright, pause the video and try this one. So we have a product and a quotient. Let's do the quotient. So we'll have natural log minus natural log of z squared. We're going to expand that. And now we can use the power property. We're done with that. Okay, solving log equations. So to solve a log equation, we have to exponentiate. We want to isolate x. So here we need to cancel the 2 and cancel the log base 3. Let's start with the 2. And we want to make this the exponent of 3. Whatever the base is, we make that the base here. 27. Alright, pause the video and try this one. So we have to remember that the base is 10. We want to make each of these the exponent of 10. So this will be x. 10 to the 1 is 10. Alright, and when we solve exponential equations, we're going to use a logarithm. Start by eliminating the 1. And now we could do any base logarithm that we want, but this can be done without a calculator if we just use log base 3. Find the exponent of 3. The exponent is 2x. And find the exponent of 3, that gives you 9. So the exponent is 2. And then divide by 2. Pause the video and try this one. Subtract 1. Divide by 2. And we have base e. Over here we had base 3, so we use log base 3. Here we have base e, so we use log base e, or natural log. And we could leave it as natural log 1/2, or you could evaluate it on a calculator. And we'll stop there.